Hey everyone, this is Dr. Mo, and this is part 1 of a Mario-style platformer game that we're going to make together. So when you run this thing, you have a pretty standard-looking platformer with gravity. The way I handled stopping the player from walking off the screen, as you can see there, is I just simply built a wall there so they can't walk off the edge. You do have the ability in this one to fall down holes and die, which resets your position. We don't actually have live set up here in this video yet, but that's a really easy fix. So not a whole lot of whistles and bells. It's just a really long map with working gravity, and you have to be a little bit careful because you can actually fall off on this one. So let's go ahead and get started. Okay, so hopefully you've done a few games with us already, so I'm not going to go into a great deal of detail in terms of the setup here. If you haven't done a lot of games, I really strongly recommend that you do the basics, Pong, Breakout, and then some sort of matrix-based game such as Pac-Man or Tron or something like that, because we'll be pulling on some of those concepts, and this might be kind of tricky and go a little too fast if you haven't done those games yet. Alright, so we've got pretty much all of the Allegro libraries that we regularly use. Don't forget to turn these on in properties. I've got some globals and constants, including some enumerations that'll handle our key bindings. I have this really long 10 by 100 map here, and you can see the ones are representing the platforms there. I recommend having this bottom line to be pretty much all ones except for a few holes, unless you want to make this really hard for your player, and then you can have a lot more zeros down there. I've made both my map and my map offset. The map offset, this is actually going to scroll the map. I've made both of these global, so all of our functions can access them. I know that global functions are generally not really the best coding practice, but I figured it'd be okay with these two because they are used by pretty much everything in this game. Speaking of offset, if you haven't seen this before, if you watch really carefully our player's position here, the player actually isn't moving. It's the map behind him in terms of his horizontal movement. He's not moving. He's always about a quarter of the way across the screen there. And we can maybe finesse this a little bit later on, where he can move a little bit. In the original Mario Brothers, you can actually move his position, but generally it's more about the map scrolling behind him. So that's what this offset's going to do down in our render section. Okay, at the moment I only have one function set up, and that's a really basic collision function. Notice I'm not actually sending the map to it as a parameter because we did make it global. Inside main here, we've got some pretty standard variables, something that handles our game loop and our render section. We've got a bunch of Allegro variables. I do have sound up and running. That's probably not a super high priority for a lot of people, just getting the physics set up. But you will see a little bit more sound code than you usually do in a first part of a video series. Player variables, the player's going to have an X and Y starting position, and then these things here, these are our player's speed or velocity. So we actually have an X velocity and a Y velocity that we're going to be impacting, and those just get added to our X and Y position. We do need some variables for gravity, so we've got that. I like to set up all of my Allegro initializations all at once, so we've got that. Here we are setting up music, and it's actually set up, like I've got the basics here for multiple sounds effects. So if you're used to only playing background music, but you haven't had actual sound effects yet, this is how this works. So we're actually going to set up like a mixer, and that's going to allow us to play multiple sounds at once. The game currently doesn't have more than one sound, it just has a background music looping, but it'll be really easy to add those sound effects later. Okay, we've got our player. At the moment, he's just an empty bitmap. We haven't loaded any pictures. I really recommend that you use a bitmap and not a primitive. Don't just have a AL draw filled rectangle down in the render section, because if you set this up as a bitmap, it's ready to have a sprite sheet loaded in later on. And since we want this to be a relatively finished looking game compared to some of our other ones, we will want to have a sprite sheet there eventually. This is saying, hey, look at that player, and clear its color to that lovely shade of red that you see in the game. Okay, I put this stuff in curly brackets so you can get rid of it. You can minimize it. You'll see that I've minimized a couple sections down in the game loop, stuff that I'm pretty sure that if you've done a couple games with us already, you should be pretty solid on. So this is a nice little trick to be able to minimize your code when you're dealing with a bigger game like this. You can just kind of skim over it. But please make sure that you do understand all this stuff. So we've created these are the 3 things absolutely necessary for games, is you got to have a game screen, obviously. You need to have an event queue, and you need to have a timer. These guys here are telling the event queue what to look for. So it's looking for timer ticks, it's looking for keyboard input, it's looking for displays, clicks, although I don't actually think this part's set up in the game loop. We'll check that in a second. And look, I have timer in there twice. Oops, sorry. Okay. And then here, so remember how we were kind of like looking at the player before? Now it's saying, hey, look at the display from now on whenever we want to like change the color of something. Just assume I'm talking about the display. So down in the render section, when we have AL clear to color, it's like, oh, that's what it wants me to change the color to. All right, we start the timer and we are ready to roll with our game loop here. Okay, so here's where I did some more minimization. So I am just going to plain old skip talking about key down and key up. If you are unfamiliar with those or shaky, I'd recommend looking either at our class webpage or the Allegro wiki is a wonderful resource. That's basically where I learned how to code, and much of my code is regularly stolen from the Allegro wiki. So yeah, we're not going to go over keyboard section. I did also just forget to put in any kind of way to close it, so you can't actually close it with the X. So when I run it, if you notice here, like this doesn't do anything because I forgot that section in my game loop. It should probably go right here, like if event type is Allegro display or something like that. So if you have that, leave it in there. It really should be in there, and you'll definitely see it in the next part. All right, so here's the good stuff. We've got the timer section. So the first thing I'm going to do is I'm going to check and see if my player has fallen down a hole, and if he has, kill him. So we're going to check the player's top left corner and add 32, so we're actually looking at his feet. And if his feet get bigger than the height of the game window, we're going to go ahead and we're going to, I haven't added this in here, but a sad sound effect should probably go here. We're going to basically just reset his position. So this is that in action. As soon as his feet hit the bottom of the game screen, bam, he's reset there. If you want to mess with this a little bit, like if you want his actual head to be able to trigger that, you can take off this. And you'll actually see him kind of sink below there a little bit more. It's a real short effect there, but you can see a little bit of it different. If you want him to actually kind of like go down there for a distance, let him really, like one of those old Bugs Bunny cartoons, really fall down there for a while. I guess 30 isn't that much. But the bigger you subtract the number, the longer he'll be falling for. So 80? Maybe try that. Yeah, so you can see he's falling for a while before he actually resets. So that's a bit extreme. Let's put that back at 20. But you can have any number here or no number if you want. Okay, if he's not falling off the screen, we're going to go ahead and assume that he's not necessarily on a platform either. That is going to be triggered by this part. So right here you see our collision function, which we'll go over down at the bottom. And if that is actually returning a 1, we're going to go ahead and set is on solid ground to true, and we are going to reset our y velocity to 0, so we are no longer going to fall. We're not going to jump either. We're just stop, up and down movement. Our collision function, which I'll go over, also stops us from colliding stops us from jumping through a platform. So in some of my previous gravity codes, like you'd be able to jump through the platform and then land on it. In this particular game, I didn't want that effect. So if you want, you can just take this out, and then you're going to be able to go bloop right through it and land on top of it. So that's kind of a style thing, but we do have our collision functions set up to do that. Okay. This guy here is stopping us from moving left or right if we bump into the side of a platform. So just like Pac-Man, if you've done that game, we are actually checking the direction we're moving when we are checking for collision. And that's just like Pac-Man, and so we don't actually get stuck into the walls. And what we're doing here is we are actually creating a bit of a bounce effect here. So what we're doing is when we collide sideways, we're going to actually just have him bounce against it slightly. So, I mean, it actually creates a little vibration thing here. But that's, again, just to really make sure we don't get stuck in that wall. And it's just kind of a neat effect. Jumping, hopefully this makes a lot of sense. So if you press the up key and we're on solid ground, go ahead and jump up. If you want to impact how high your jump is, this number can be smaller to make a smaller jump. I think 15 is pretty good for this map size. You can comment this out if you want to get double jump going for yourself. So basically allowing your character to fly. Probably not a good idea for most games, but there might be a game where you want to be able to let your character always jump. At the moment, when you do this, he can only jump when his feet are touching a platform. Okay, this is a bit of a change if you haven't worked with a game like Geometry Dash or another scrolling game. When we move left and right, we're not actually impacting we're not going to be impacting the player's motion. Position. We're going to be impacting, I mean, it does say player velocity here, but what we're going to do is we're going to be adding this to the offset, not necessarily to the player's position. But this should look pretty familiar. It's just what we're going to do with it. That's weird. Here's the actual gravity code right here. When we're not on solid ground, we are going to be falling. If you want to make him fall faster, obviously make that number bigger or smaller if you want him to kind of have the feather falling effect. Friction. So this is going to actually do exactly what it sounds like. When you have a 0.8, it's going to stop pretty quickly. The closer this number gets to 1, so let me show you with like 0.95, the more slippery it's going to be. So you can kind of see I've got a little bit of a slide going there before I actually come to a stop. Make it closer, like 0.99. See, it takes a while. Am I going to go... Oh, I almost went down the hole on that first jump there. If you set it to a 1, basically you're just not going to stop. Like, as soon as you go one direction, you keep going in that direction until you just change your direction. So, yeah. And if you make it too small of a number, like 0.1, you're just not really going to be able to move at all. Like, I'm pressing my right key here, and it's just right and left. It's just too much of a friction effect. So I think 0.8 is a nice number, but you're welcome to mess around with this. Okay, this is kind of embarrassing. I actually don't know why, but there was this funny bug that like friction wasn't really working in the left-hand direction, and I think it has something to do with the offset. Like it worked fine in the right. And so I just did this kind of little hack here. I just said, hey, you know, if we're between here, just set it to 0. Let's skip all those decimals in there. So this was just a little hack I did to get this to work in the left-hand direction. I'm kind of in a rush to get this video out for a few of my students right now, so I didn't really have a chance to figure out what exactly I was doing wrong, but this actually does work. All right, terminal velocity, probably not really needed in this game because we're not ever falling too far, but this stops us from falling too fast. And then here's where we're actually changing the map instead of the player position. Y position is still changed, but we're changing the map offset. And we'll talk about that in our next video.